All right, the next test are combining the alternating series test with all the other tests that we've had, and that adds a little bit of chaos. So before we do anything, we're first going to remove the alternating part and determine if that converges. If the non-alternating part converges, it is said to converge absolutely. If the non-alternating part does not converge, and you move on to AST, the alternating series test, and you can get convergence then, that is called a conditional convergence, which is a weaker statement. And of course, if you get divergence any way along the path, then it diverges. If you are using an absolute value test, which are the ratio test, the root test, and the geometric test. All of those have absolute values in them. And if you get inconclusive from them, they will not diverge. And you do not need to go on and check for conditional convergence. All right, so looking at these ones, the first one, we always check for convergent absolutely first. So we get rid of the alternating piece. That is p equals 4, so therefore it converges. It converges absolutely. You do not need to move on. You're done. Here, if I try to do convergent absolutely, which means I look at this one, it diverges with p equals 1/3, p series. So since that diverges, now we're going to check for conditional convergence. The only test that checks for conditional convergence is AST. So the limit is equal to 0. Sorry, there's a little typo on that one. Let me fix that real quick. This should be 1 over that is equal to 0. And f prime of is less than 0. So therefore it converges conditionally by AST. Here, you see how it diverges? By nth term test, do not go on. It diverges by nth term test, do not go on. Here, looking at this, I'm not even exactly sure what it would do. I see that factor on the bottom, so I'm expecting converge. So we're going to go for convergent absolutely by ratio. One thing we should notice is that any p series will converge. If it converged without it alternating, then it will converge absolutely. If it diverged, if it didn't alternate, then it will converge conditionally. It doesn't matter if you have to do a comparison to a p series, this always holds. So for example, if I look at this one, the first one I would compare to 1 over n squared. So I know this original one is going to converge absolutely because this one converges absolutely. If we had something that looked like this, right here, if I tried for converge absolutely, I'd compare it to 1 over n. I know this one diverges, so therefore we'd go for a conditional convergence with AST. Anything that can be compared to a p series will at least converge conditionally if it alternates.